This is Bob Capetta, and this lesson is on sampling in statistics. So here's our question. The college administrator wants to know the proportion of current undergraduates who would support a fee increase in order to improve the fitness facilities on campus. So let's think about that process. How are you going to ask the question, and who are you going to ask? And what are those numbers going to mean? So here are our goals. We need to identify the population of interest. So what is a population, and what are we going to ask them? Secondly, we need to identify potential strategies for creating random samples. If we're not going to ask everybody in the population, we're going to create some representative group. We're going to make inferences for the entire group based on analyzing what we get from a smaller sample. And finally, we want to compare and contrast the numbers that reflect the population and the numbers that reflect a sample. So we have a single population, many possible samples. We want to think about the process that's involved. So what is a population? What are we looking for? In statistics, what does that term mean? Well, the population is the entire set of elements whose properties are being examined by the researcher. So all of the people we are interested in. So in this case, the people we want to ask are all of the undergraduates in this institution. Now at a large school like Ohio State or University of Central Florida, 40, 50, 60,000 possible undergraduates, too many to be able to ask. So when we do statistics, we create a representative sample. That's going to be our goal. And what do we want to know about those people? So our population is everybody, all the undergraduates at the school. We're interested in the proportion of all of those who support the fee increase. So for the sake of discussion, let's say we have 50,000 undergraduates. And let's assume 20,000 of them are interested in the fee increase to improve the fitness facilities. That would be the proportion for the entire population, 20,000 out of 50,000, or 0.4. But the reality is, most of the time, asking everybody in the population is not feasible, is not realistic. So that's what I'm going to ask. Is it feasible, or is it even necessary to study every single individual in the population? That's what we want to ask ourselves. Now, if we ask everybody in the population, it's called a census. So here is a definition from the internet, and you can see the citation at the bottom of the slide. These folks say that a census studies every member of a population. It results in a parameter for a population. So a number that reflects a population is a parameter as opposed to a statistic. We'll talk about those terms later. Basically, a parameter contains information about everyone in the population, while a statistic only tells you something about a small part of that population. Studying every member of a population is usually not practical because of finances or time constraints. With the exception of the U.S. Census, censuses are very rare. But the reality is even the U.S. Census fails to be a proper census because we do not include everybody in the population. There are individuals who refuse to participate. Therefore, you are just getting a convenience sample of people that choose to submit the materials. So even the U.S. Census, the one case I can think of that attempts to look at everyone in the population, fails to do so. So in statistics, rather than looking at the entire population, asking questions of everybody, we need to create a random sample, sometimes called a simple random sample. And a random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for that sample. Every individual in the population needs to have an equally likely chance of being selected. That's what makes it a random sample. And this is much harder than it sounds like. So let's look at some examples and see if you think these are examples of random samples. So here's the first one. We're going to post the fee question on the University Learning Management System and give students the opportunity to respond whether they support it. So we post it on the LMS. Every student can see it, but the students have to decide whether or not they're going to respond to the question. So students choose whether or not to participate. This is a bias. This is not a random sample. This is what we call self-selection bias. So no, I do not believe that would give us a random sample. And if your sample isn't random, you really cannot make inferences from that sample to the entire population. For example, maybe you had student leaders who really wanted the new fitness center, so they might tell all of their friends, make sure you go on the LMS and answer this question. And they will bias the results. It will not be reflective of the entire population. So no, that would not be a random sample. We've seen this in many locations. Researchers stand with a clipboard and approach undergraduates and ask them if they support the fee. This sounds like it could be better, except there's a couple problems here. Where are they standing? Maybe they're standing in a location that freshmen frequent, but not a section of the campus where seniors frequent. And the other obvious problem is if students see someone coming at them with a clipboard, they may choose to walk the other way. So I would argue this is also an example of self-selection bias. Students are choosing to participate, and it may not be representative of the entire population because we do not know if the location where the people are standing really encompasses everybody. Go to a student club fair, so all of the students involved in the student clubs are there, and just ask them if they support the fee. This is not representative. People in student clubs may be more likely to support fees than students who don't. So that again would not be representative. Finally, assign each undergraduate a number, randomly select 250 numbers, contact each student whose number corresponds to the one selected. Now this is the best of the four, but you still have a problem. You've got to contact those people. How? On the phone, and as you know, they may choose not to answer the phone. On an email, they may choose not to answer the email. So the best way that this is typically done nowadays is, yes, you're going to try to contact those 250 people 3 different times to give them the greatest opportunity to participate. And if they fail to participate all 3 times, then you just realize that that person is going to have to be removed from our sample. But creating a random sample seems like a simple thing, but in reality is a very, very complex process. And there's an entire area of statistics called design of experiments where you look at that very carefully. All right, what is a parameter? This was mentioned in our discussion on a census. A parameter is a number that reflects a characteristic of the entire population. But the only way we study the entire population is by doing a census, and that is rarely ever practical. So here's our question. The college administrator wants to know the proportion of current undergraduates who support the fee increase for the fitness facilities. So what's our population? Population, everybody we want to study. Population, all current undergraduates. The number we want to know is the proportion of all current undergraduates who support that fee. So that's the relevant parameter that we're interested in. Proportion of all undergraduates who support a fee increase in order to improve the fitness facilities on campus. That would be the parameter. Again, looking at all undergraduates. But to get that would require a census. We would have to ask every single undergraduate on campus. Now, how about a statistic? What are we going to say about this? So that's a number that reflects a characteristic of a random sample. Now, if it's really a random sample, each element of the population must have an equal chance of being selected for that sample. And as we showed earlier, that can get kind of difficult. So here's our question. The college administrator wants to know what portion of the undergraduates support the fee increase. So our statistic here has to come from a random sample. So let's assume that we used a random number generator. We came up with 250 numbers. Every number is assigned to a student. So we get 250 students and we do our best to get them to participate. The proportion of that group, let's say it's 250 people, a random sample of 250 that we ask. The proportion of that 250 people is our relevant statistic. Now, is the proportion of the 250 people the same as the proportion of everybody? Probably not exactly the same. But this is the power of statistics, of inferential statistics in particular. If you properly design your experiment, if you really have a random sample, then a statistic from that sample should tell you something about the parameter for the entire population. So that's what the study of inferential statistics is. If a sample is large enough and randomly selected, it is fair to make inferences about a population by examining the characteristics of the sample. This is hugely important. Recognize just how nice this is. A small, representative, random sample tells us everything we need to know. I remember once hearing someone complain about ratings on the radio, and the Radio Personalities said he didn't think the ratings were fair because he didn't know anybody who ever participated in a rating survey. Well, the reality is it's a small number of people who are going to participate, but if it is randomly chosen, that should do a pretty good job of saying what happens for the entire population. Okay, let's take a look at another experiment and talk about some of these terms in this context. So a researcher wants to know the average income for likely voters in the next presidential election. So what's our population? Our population is all likely voters. So that's everybody we want to study, all likely voters in the next presidential election. Is that well defined? Something to think about. What's the sample? Well, we need to create a random sample from all likely voters. How are we going to do this? Not easy. Not easy to do. But the sample will be a random collection of people from the entire population of all likely voters. What's the parameter? Assuming we could do a census, and we had the entire population of all likely voters in the next presidential election. If we had everybody's income, the relevant parameter would be the average income for everybody among all likely voters in the next election. That's our relevant parameter. A relevant statistic, well, we're going to get a sample of a couple hundred people. We're going to take their average income, and that should, if the sample is truly random, representative group, that average for that small group should fairly well predict the average for the entire population. Now, discuss some challenges inherent in the study. The couple big issues. How do you know who is really a likely voter? If people voted in the last election, that's usually a pretty good sign. But just because someone voted in the last election doesn't mean they're going to vote in the next. That is a common problem that we see. Someone may say they're going to vote when in fact they're not going to. So how do you decide likely voters? Very, very difficult. You want to get their incomes. How do you know people are being honest with you if you ask them their income? Some people may exaggerate one way or the other. And finally, how do you really get a random sample? We don't know who all the likely voters are. How do you simply and easily create a way where everybody has an equally likely chance of being selected? So you can see there are many, many challenges in doing statistics well. So let's review some of these terms. This lesson really was about the terms. The first term we had is the population. So that's the entire set of elements whose properties are being examined. So in our first example, it was all undergraduates at the college. Second group, our population, was all likely voters in the next presidential election. So everybody that is to be studied. Now what's a random sample? Because we cannot typically do a census, which is asking everybody in the population. So a random sample is one in which every element, every person, every item in the population has an equal chance of being selected. Very, very difficult to do. Very difficult to do. A parameter is a number that reflects a characteristic of the population. That's what we want to know. You want to know the proportion of all undergraduates who support the fee increase. You want to know the average income of all likely voters in the next presidential election. That's difficult to find. Frankly, it's impractical and much too expensive. So instead what we do is we take a random sample and find a number that reflects that. And that is a statistic. So the term statistic, as it is used in this context, a statistic is a number that reflects a characteristic of a random sample. In our two examples here, we looked at proportion and we looked at an average. So those would be two characteristics of a sample, and then we make inferences. Studying the sample, a small subset of the entire population, we make some inferences about the behavior of the entire population. We expect that our statistics are fairly close, the numbers are fairly close to the actual parameters. And that will conclude this lesson.